If f of x is equal to c, where c is constant, then f prime of x is equal to 0. The derivative of a constant is equal to 0. For example, f of x is equal to 3, where 3 is constant. Therefore, f prime of x is equal to 0. We can conclude that all derivatives of a constant is always equal to 0. Next, we have power rule and constant multiple rule. We use power rule if f of x is equal to x raised to n, where n is element of n, then f prime of x is equal to n x raised to n minus 1, and constant multiple rule if f of x is equal to kh of x, where k is a constant, then f prime of x is equal to kh prime x. For example, f of x is equal to 2x squared. To differentiate it, we multiply the exponent to numerical coefficient and subtract 1 to the exponent. For example number 2, f of x is equal to 3x squared. Like we did in number 1, we multiply the exponent to numerical coefficient and subtract 1 to the exponent. Then, we have the sum rule. If f of x is equal to g of x plus h of x, where g and h are differentiable function, then f prime of x is equal to g prime of x plus h prime of x. For example, f of x is equal to x squared plus 2x. We differentiate x squared and 2x individually using power rule, which will become f prime of x is equal to 2x plus 2. The product rule, if f and g are differentiable functions, then dx quantity f of x, g of x is equal to f of x, g prime of x plus g of x, f prime x. For example, f of x is equal to 3x squared minus 4 times x squared minus 3x, where 3x squared minus 4 is f of x and x squared minus 3x is g of x. We let f of x stay as is and differentiate g of x plus g of x and differentiate f of x. Then we simplify it and it will become f prime of x is equal to 12x cubed minus 27x squared minus 3x plus 12. Next is the quotient rule. First, f of x and g of x be two differentiable functions with g of x is not equal to 0. Then, d of x quantity f of x all over g of x is equal to g of x f prime of x minus f of x g prime of x all over quantity g of x squared. For example, f of x is equal to 3x plus 5 divided by x squared plus 4, where 3x plus 5 is f of x and x squared plus 4 is g of x. We use the formula dx quantity f of x all over g of x and substitute the values and then simplify. And we have f prime of x is equal to negative 3x squared minus 10x plus 12 all over x raised to 4 plus 8x squared plus 16. Derivatives of trigonometric functions. A. dx sine x is equal to cosine x. B. dx cosine x is equal to negative sine x. C. dx tangent x is equal to secant squared x. D. dx cotangent x is equal to negative cosecant squared x. E. dx secant x is equal to secant x tangent x. F. dx cosecant x is equal to negative cosecant x cotangent x. Lastly, we have the derivative of an exponential function. If f of x is equal to e raised to x, then f prime of x is equal to e raised to n. That's all. Thank you.